Hey guys, in this video I'm going to explain the fourth logic game of LSAT Prep Test 74, which is the December 2014 LSAT. This game is a grouping game, specifically I would call it a splitting game, where we are assigning the variables to one of two categories, both of which are present. Of course, in this game, some of the variables can also be out. So it's a little bit undetermined what's going to happen with regard to numbers, but we do know we're going to have at least 4 in total, at least 2 on each side. So I've laid out some rules and inferences here. I'll explain everything. We know that F and H must go together, so I've put them together in a vertical block, and that means they can go either in S together or in T together. We know L and M cannot be together. If G goes to S, then L goes to T. So right away I would do the contrapositive. If L does not go to T, then G does not go to S. And we can combine this with the following rule, which talks about M, because L and M are connected in that they cannot be together. So if K does not go to T, H and M will go to T, contrapositive. Either H or M does not go to T, then K will go to T. This combines with the LT rule, since L and M can never be together. So we get a big web of relationships. Very important to spot this important inference to help you throughout the rest of the game. So make sure you understand how they're all connected. Now, let's go on to the questions with the two major diagrams that either F and H are together on S or they are together on T. Now, right away, actually, we can say H is not going to T here. Therefore, in this diagram, K is going to T. So we get a nice little inference there right off the bat. We can't do this with the other diagram, though, since HT doesn't really lead to anything in particular, and F is not involved in the chains, but good little thing to add in right there. Let's go on to the questions, starting with number 17, which is a general orientation question. So here we'll just take one ruler inference and apply it to all 5 answer choices, checking for violations. We know that F and H must always be together and in, so right away B is gone since it does not have either F or H at all even. We know that L and M can never be together, so C is violating that, and that's out. We know that GS requires LT. A is violating that, so that's gone. And finally, we know that if K doesn't go to T, then H and M will. So in D, K is not going to T, but H and M did not go to T, so D is gone, giving us E by elimination for number 17. Next, number 18, if H and L are together. So we can just use our templates. I've added L onto each of these, of our two main diagrams. We know that if L doesn't go to T, then G doesn't go to S. L didn't go to T here, so G is not going to S in this diagram. Of course, M is not going there either, because L and M are never together. We're going to need to put something else on the top diagram in order to have 2 on each side. We've used F, G, H, K, L, M. Look at that, there's nothing remaining to possibly go there except G, so we'll have to stick G right here. Again, L not going to T means G is not going to S. So we've got that diagram taken care of. Bottom diagram, we know that if L does go to T, M will not go there, and K will go to T, leaving M and G to go to S. Whatever, not important, they're just, we'll just run through the choices now. F go to T, is that a must? Doesn't happen in the top diagram. A is gone. G go to S, must that happen? Didn't happen in the bottom, didn't happen in the top again, so that's gone. G go to neither. No, actually, we do have G going places. K go to T happens in both, that's our answer. L go to T did not happen in both anyway, so D is our answer for 18. Next, number 19. General could be true question about S. We'll just run through the choices. Looking at A, could that work? Well, let's use our knowledge that GS leads to things. GS requires LT, which requires KT, but we've got K on S here, so A is gone. B, let's see if that complies with GS. We don't have L there, we don't have K there. That's all good, looking okay for now. Looking at C, GS again, GS requires KT, but we've got K there, so that's gone. Next, looking at D, H and L, doesn't work. F and H always have to be together, so D's out. Looking at E, K, M, well, if M is on S, that means it's not on T, and if M is not on T, then K has to be on T. So E's out as well, leaving B by elimination for number 19. Number 20 is a very general question involving a major inference that we haven't made yet. So let's skip that one and come back to it. And let's go on to 21, hoping that the information there will help us out. So if we have exactly 4 photographers, we can just use these two main diagrams. Right here, they're asking who must go on S. So we can use these as our basis and see maybe one of them will be invalid in some way to have only 4 there. So if we had just these 4, that means K is not going to T, so we'd have to have H and M on T. There's no room to have M on T here because we only have 2 things. So for that reason, this bottom diagram isn't going to work, and we're left specifically with the top one. So we see here then that we have to have both F and H in S, and so H isn't a choice, but F is, so A is our answer to 21. Having K in is pretty fundamental to the game. I mean, we don't really care who exactly this 4th variable is going to be. If we were looking back at number 20 for a moment, thinking about who has to be in period, we know F and H have to be in, of course. We know K has to be in T on this side, but could we make a valid scenario with someone else? We could put L here perhaps, we could put M here perhaps, we could put G here perhaps. Any of those guys, could probably, go in here, and we're not activating any problems. We're not causing any problems, but K is sticking there. So it turns out that we don't have to have G. We don't have to have M, just generally speaking here. So our answer to 20 is going to be just F, H, and K. So we actually solve both 21 and 20 with this knowledge right here. And so B is our answer for 20 as well. Let's move on to number 22. So number 22, which cannot be the complete assignment at T. So 4 of these will be perfectly fine. One of them causes a problem. So we'll just run through the choices. F, G, H, M on T leaves K and L on S. So if K's on S, that means it's not at T, so we're activating the big chain here. H and M at T, perfectly fine. G at T, perfectly fine. F and H go together, of course, so no issues with A. Let's take a look at B. F, H, K, M. That leaves G and L to be at S. GS requires LT, but they're saying we've got L at S. Unacceptable, so B's our answer for number 22. By the way, you can actually eliminate C off the bat because that's what happened in 17 choice E. So little using previous work there. Finally, number 23, this is one of those dreaded rule substitution questions. They're asking us what would have the exact same effect, changing nothing. So you want a rule that is no more limiting than the original and no less limiting than the original. So let's scan through the choices, see if anything jumps out. We've got a few mentioning the word unless, and of course the word unless can be translated to mean if not. So the first two start off if k in a positive sense, if k is going to s, but the last three all say unless, so that if you translate to if not, that's negative. But C and D both say unless k is at t, meaning if k is not at t. And we have a big chain about what happens when k is not at t. So I want to start by focusing on those two choices. C says if not kt, then f and m are at t. That's very similar to this. It's just changing ht into ft. It's leaving m the same. Now, h and f are pretty much interchangeable in this game. They always have to be together. There's no major differences between them other than their involvement in this rule. So if we just switch f and h, it would have exactly the same effect, meaning that C is our answer for number 23. And that's the game.